and welcome Mindsetters to this session of Learn Extra Live. I hope you guys are having a good break. Well, not even a break. Well, actually, making sure that your brain doesn't break by keeping it fed.
You got yourself tongue-tied there.
I
Hey?
did.
You thought we were just come back from an ad break.
Because, like, all my shows just kind of blend in.
Uh,
But
nah.
anyway, Mindsetters, this is grade 11, Learn Extra. Make sure that you guys are ready. You've got your pens and pads out and you're going to make some notes. I'm Ty. I've got Peter here with me. He's going to be taking through the session. How are you, Peter?
Absolutely. Welcome, guys. It's Thursday evening, and Thursday means two things. One, it means it's time for mathematical literacy, and two, it means it's quarter to Friday. And that's exciting, isn't it?
Yes.
But I think the mathlet should be the more exciting thing. All right.
That should definitely be the priority
It should
here.
be, absolutely. And guys, today we have a great show for you. Today we're going to be looking at some shapes. So we're going to be looking at perimeter, we're going to be looking at area, seeing the difference between the two. A lot of revision with that, okay? So if you're grade 12 and you're watching, don't forget that grade 12 includes grade 11 work. So I should hope that right now we got a bunch of grade 11s watching as well as a bunch of grade 12s, okay? I'm going there, you talking about this? and
The
we'll-
whole computer thing.
Cool.
Okay. So while Peter heads over to the board, Mindsetters, you know the drill, you know the link, www.facebook.com/learn extra. Get on the page, talk to me, let me know what you guys are thinking. If you're lost anywhere, if you need help, post. Guys, I cannot help you if you don't help yourself by posting in front on the page. So make sure you're sitting there in front of the TV with your phone, with your books, or if you're using a laptop. But let us know what you guys are thinking. We cannot read your minds through the screen, so the only way we can help you is to help yourself by posting on the page. But for now, that's where I get off my little podium, and then I say, anyway, Peter, take it away.
Right, great. Thanks for that, Ty. Right, folk, we said we're looking at perimeters and we're looking at areas. Okay, so what I thought we'd do, we'd start with some basic little calculations with perimeter. Then we're going to look at some basic little calculations with area. And then I'm going to show you something very, very interesting. How one can take the same perimeter, okay, but make a different area. Ooh. And that should be quite interesting, and hopefully I won't forget to do that. Okay, so let's start here. Our first question of the day. With the use of calculations and diagrams below, determine, first of all, which shape has a larger perimeter. Now, folk, what do we mean by perimeter? You know that a perimeter, or you should know at this stage, towards the end of the year, that a perimeter is the outside distance of a shape. So it's like, and I always use this little example, it's like taking a little ant, putting it on a shape, okay, putting it on the line and saying, walk, pal, and he walks all the way along the line. And eventually he gets back to his starting position. Now, if we had to measure that distance that he walked, that would be our perimeter. Okay, so when we look at our shapes, we're giving you a number of shapes. We're giving you a circle today, we're giving you a triangle, and we're giving you a rectangle. Good old paper one type questions. So, first thing, let's find the perimeter of our circle. Now, the perimeter of a circle, folk, is equal to 2 times pi times r. What's another name for the perimeter of a circle? It's my circumference. Okay, so in an exam, your teacher could say, calculate the perimeter of that circle. Or they could say, hey, what's the circumference of that circle? Both are, we're talking about the perimeter. The circumference of a circle or the perimeter of a circle. Okay, so we are now going to calculate that, and we know that the perimeter of a circle is 2 times pi times r. Now, I want to point out something. This is so important. This thing. Diameter equals. Folk, here's a little clue. Whether you're in grade 10, whether you're in grade 11, or whether you're in grade 12, very, very seldom do we deal with diameter. And I always say to my students, when you see that word diameter, it's like an ugly word. Get rid of it. Change that word to radius. Because in our formulas, normally we tell you 2 times pi times radius. Okay, for circumference, we could actually say the circumference is pi times the diameter. But in this case, it's asking us for radius. So let's do this. We're going to say, if the diameter is 10, my radius must be 5 meters. Now, what's the difference between a diameter and a radius? A diameter is if I've got a circle, My diameter, Ty, I need you here. Come stand here. Come stand here. You've got to work today, pal. Make a circle with your hands. Okay, cool. So the diameter would be this whole distance from the one end of the circle to the other, but it's got to go through the center of the circle. It can't be a little line like this. It's got to go through the center. So what's the radius then? The radius is now from the middle of my circle, let me show you here, to the circumference. That would be my radius, okay? Diameter from one side of the circle to the other through the center. Radius from the center of the circle to the circumference. Do we understand that? Okay, very, very basic concepts. How long are you going to stand here holding a circle?
Just waiting on your cue, pretty much.
Okay, well, I think we've done. All right, you can stand here if you want to. But I'm going to move on. Okay, so there is my circle. My radius is 5. Now let's apply the formula. 2 times pi times r. So I'm going to go and say, right, my circumference, or the perimeter of my circle, is 2 times pi times my radius. 2 times, now, latest thing happening in mathematical literacy, when I say latest, it's been the last 3 or 4 years, you cannot push pi on your calculator, okay? Your examiner will say, here's the formula, circumference of a circle is equal to 2 times pi times r, let pi equal 3,14. And guys, if your examiner tells you that pi must equal 3,14, then make it equal to 3,14. So I'm going to say 2 times 3,14 times my radius, which we said was 5 meters, equals. Now we're going to let our calculator do the work for us. Okay, so we're going to say, right, 2 multiplied by 3.14 multiplied by my radius, which is 5, and my answer now is going to be 31,4. Okay, 31,4. 31,4 what? 31,4 meters. Okay, remember when we're dealing in perimeter, our unit is just the unit that we're dealing with. If we were dealing in area, it would be our units squared. If we were dealing in volume, it would be our units cubed. Got that? I say that quite often, don't I? But it's something you've got to remember. And sadly, it's something a lot of people in matric forget about. So I've got 31,4 meters. Done, finished. Next question. Calculate the area of the triangle. Now, the triangle, in fact, you know what? I'm going to come back to the triangle because there's a little trick in there, and we'll leave the best part for last. Let's look at the rectangle. So here's my rectangle, and I'm going to say the perimeter of my rectangle is equal to, now, do they give us the formula for it? I hope not. Oh, good, they don't. Because I would like to tell you this. If you don't know how to calculate the perimeter of a rectangle, folk, you've got a problem. Because a perimeter of any shape, okay, besides the triangle and the circle, all you're doing is you're adding up the lengths of the sides. So what you're actually saying is this: for this rectangle, if I start at this point and I travel to this point, I'm traveling 10 meters. Plus, this point to this point over here is 6,5 meters. Plus another 10 meters, plus another 6,5 meters. Equals. Now, we take out our calculator, and we're going to work on our calculator. Now, I've had a number of people saying to me, Peter, you always use a calculator, when quite frankly, you could just use your head and get that answer. I mean, if we had a look at this calculation, let's have a look at it. 6,5 is going to give me 13, plus 10, 23, plus 10, 33. Why are we using a calculator? Guys, because when I'm busy in an exam, hey, I get very tense. I get very anxious, and I can make silly, careless mistakes. And so I always say to my guys, you know what? You can do it in your head, but just check yourself on the calculator, just in case you've made that silly mistake. So let's have a look at it. So on my calculator then, and we already know the answer because I told you what it was, but let's pretend we don't. We're going to say 10 plus 6.5 plus 10 plus 6.5, and there's my answer, 33 meters. Okay, so 33 meters is my answer there. Okay, now for the triangle. Now, the area of a triangle, the formula is quite simple. If you look at it, it says the area of a triangle, in fact, it doesn't give it to us at all, but we know what it is, hey? We know that the area of a triangle, perimeter, is equal to half times, in fact, what am I doing? We're doing area here. Let's get rid of that. The teacher's made a careless mistake. Let's pretend that hasn't happened. Okay, so what we're doing is we're finding the perimeter. So we're saying, let's add up from this corner to this corner and to that corner and back to our starting points. So it's quite simple, hey? All we're going to do is we're going to say, well, 5 plus 13 plus, something's wrong. We've got a 5. We got 13, and then we got something missing. And we got to calculate that missing little thing. What are we going to do? Folk, look at this here. We told the perimeter of a circle, and we used that. We said, thank you very much. I've used that. I don't need to use it again. We used the fact that pi is equal to 3,14. I don't need to use it again. But when I look here, there's something I haven't used. And it's Pythagoras' theorem. Now, folk, I say this all the time. Next year, when you're watching and you're in matric, I'm going to say this again. So let me go ahead and say it. And it's quite simple. No examiner is going to give you a formula if you don't need to use it. Okay? Or they shouldn't anyway, right? And in matric, they're not going to just give you a whack of formulas and say, here's a whole lot. Choose whatever you want to use. No, they are going to give you that formula. So when we look here, we see Pythagoras' theorem, and we haven't used that theorem, that formula yet. We're going to have to use it. And where are we going to use it? We are going to use it right here by our right angle triangle. So let's go for it. Now we know the perimeter of this triangle, perimeter equals, and let's add it up. So if we're going to start at this point, let's start at this point, shall we? Okay. We know we've got 5 meters, so I'm going to say I've got 5 meters plus this other side here is 13 meters. So we're going to say plus 13 meters plus this side over here, which I don't know at all. Oh, now I've got a problem, okay? Because I should know what that side is. But my examiner has given me a little clue, because he has told me that the theorem of Pythagoras states the following. And to use Pythagoras, I've got to have a right angle triangle. And I do. There it is, right there. And so Pythagoras' theorem is going to say this. Let's say a squared plus b squared. Oh, this is wrong, hey? It should be a squared equals b squared plus c squared. So what we're going to say is this. That to find the one side of my triangle, and what am I trying to find? A long side or a short side? I'm trying to find a short side. And when I'm trying to find a short side, I take a long side minus the short side will give me the other short side. If I'm trying to find a long side, I say the one short side plus the other short side. Okay, so I'm going to add when I'm trying to find the long side. When I'm trying to find one of the short sides, I'm going to do a little bit of subtraction. Okay? Can I show you why we do that? I have shown you before, but let's just do it again because I love it. I think it's exciting, it's wonderful, and it's just what maths is all about. Okay, so if I were to give you a triangle, and here's a triangle over there, okay, and we made this side 5 centimeters, we made this side 4 centimeters, and we made this side here 3 centimeters. If I drew a square on each of these sides, okay, and by drawing a square, we're saying that each of these sides, this is 5, that's 5 centimeters, 5 centimeters, 5 centimeters. Now, how do you find a square? You're going to say the one side times the other, okay, is going to give me the area of that square. So the area, 5 times 5 is 25 units squared. But let's not worry about the units now. 3 times 3 is 9. 4 times 4 is 16. Remember, if this side's 4, this side's also 4. If this side is 3, this side's also 3. And the way we find the area is by saying 3 times 3 is 9, 4 times 4 is 16. Now, look at this. What is 16 plus 9? Gives me 25. What is 25 minus 9? Going to give me 16. What is 25 minus 16? It's going to give me 9. Right. So that's why when I'm trying to find a long area, big area, I add the two short ones. When I'm trying to find a short little area, I take the long one side minus the short side squared. Got it? Okay. Lovely diagram that. I love it because it explains Pythagoras so nicely. So let's go back to this. What are we trying to find? We're trying to find this side, which is a short side. How do I know that's a short side? I know that's a short side because it's the long side is always the side opposite the 90-degree angle. And if you look here, let's get rid of this. I've drawn so much all over the place, you can't even see the 90-degree angle anymore. So here's my 90-degree angle. The side opposite that is the 13. So that's my long side. So I'm trying to find a short side. So I'm going to say the side squared is equal to 13 squared minus 5 squared. So it's the big square minus the little square. Can you see where the square comes from? Okay, it's the big square minus the little square. And that's where we put the little square. Right. So now, what is 13 squared? You know it's 169. What is 5 squared? You know it's 25. 169 minus 25 is going to give me 144. Now, what have we found? Guys, we have not found the length of the side. We have found the area of that box. Okay, so how do we just find the side? We're going to square root 144. So I say to myself, what times what gives me 144? And my answer is going to be 12. Or I could do it on a calculator. Let's do that. So we take out our calculator and we say, right, we want to find the square root of 144, and our answer this year is 12. Okay, so my answer here is going to be 12. Now we know the length of the side, 12 meters. Okay, now all we got to do is add up all those sides. So we knew the one was 5, the one was 13, and we've just discovered the other one to be 12. So let's go for it. And why not? Let's use our calculator. Okay, it's Thursday afternoon. Why should we think? So we've got 13 plus 5 plus 12, and there's our answer of 30. So we now know that is 30 meters. So we found the perimeter of our circle, we found the perimeter of our rectangle, and we found the perimeter of our triangle. Got it? Just by adding up all the sides. We did have a problem with the triangle because there was one side we didn't know, but thanks to the theorem of Pythagoras, we were able to solve that. Okay? And so those are all my lengths. Have I answered the question? Guys, how do I know I finished the question? I read the question again. So let's read this question again. Here we go. Which shape has a larger perimeter? Guys, I haven't answered the question, hey? All I've done is I've calculated the different lengths of the perimeters, but I haven't answered. So let's look. My circle was 31. My perimeter was 33. My triangle was 30. My answer, my rectangle has the greater perimeter. Okay. After this break, we're going to look at area.
All right. So yes, make sure you don't vacate your area that you're in. Get it? Nice little math. Anyway, don't make sure you come back and stay tuned. We'll see you after this break. We're back on the program. Make sure you get on the page. Keep chatting to me. I'm loving what's happening. I'm seeing Tobago's on, Mo's on. Guys, just keep on posting. Let me know what you guys are thinking. If you have any questions, let us know. But on that note, this is where I hand over to Peter. Peter, take it away.
Right, great guys. And we're busy looking at perimeters and area. And just before the break, we had a look at calculating the perimeter of a circle, calculating the perimeter of a rectangle, and also calculating the perimeter of a triangle. And in order to calculate that perimeter of a triangle, we had to look at Pythagoras' theorem. Okay, now we're going to give you those exact same measurements on those exact same shapes, but let's look at the question. Which shape has a larger area? And check the formulas they give us. Eh? Area of a rectangle, length times breadth. Area of a circle, 2 times pi times r. area of a triangle, half times the base times perpendicular height. Okay, so now what we're going to do is we're going to try and solve it. Area of a circle should not be 2 times pi times r. Hey guys, it's pi times r squared. Sorry about that. Seems that a little slip with the typing came up there. So the area of a circle is pi times r squared. Now, what I've done is I've had a look at our diagrams, and to make life interesting, I've included the perimeters of those shapes that we calculated in the question before this. Because it's going to be quite interesting to look at this and say, if a shape has the greatest perimeter, does it mean it has the greatest area? Let's try and figure that one out. Okay, so let's do it. First thing, let's calculate the area of a circle. So the area of a circle, area, is pi times r squared. Now pi, we're told we've got to use 3,14, and that's what we're going to do. Do you remember I said to you diameter is 10? Let's get rid of that diameter, and right, radius is 5. Radius is a much smaller word to use. Diameter is a big, ugly word, and we don't like to use big, ugly words. We like to use small, little, nice words. So diameter, radius. Okay, so let's get rid of the diameter and use the radius. Right, so radius is 5. So pi times r squared, and the r is 5, so it's 3,14 times 5 squared. Now, folk, I want to bring this to your attention. It seems silly, doesn't it? Pi times r squared. And do you know that we have so many matrics, and I know you're grade 11, but we have so many matrics at the end of their final year forget to square the radius. So many of them here would say 3,14 times 5 equals, get an answer, sit back, smile, and say, oh, that was easy. Okay? And the markers look at it, and they look at it, and say, oh, easy, this is wrong, and sit back, and they also smile. Okay? Guys, don't forget, check your formulas. So 3,15 times r squared. Let's do that on our calculator. Clear my calculator, and we've got 3.14 multiplied by 5 squared equals, and there's my answer, 78,5. So I've got 78,5. 78,5 what? Well, we're dealing in meters, hey? So we know we've got to have meters here, but we're not looking at perimeter. We are dealing with the area. And as soon as we're calculating area, we know it's the unit squared. So I've got 78,5 meters squared. I'm going to write that up right here in the shape. I've got area 78,5 meters squared. Now let's calculate the area of my rectangle. Now the area of a rectangle is basically length times breadth. I hope this examiner didn't tell us this. Let's have a look. Oh, my goodness, he did too. Okay. I don't like that at all. Folk, I would sincerely hope that you know that the formula for the area of a rectangle is length times breadth. You should know that by now. So, how long is my rectangle? It's 10 meters. Times the breadth. How wide is it? 6,5 meters. And you should be able to do this. 10 times 6,5, 65 meters squared. So let's write that into our shape as well. The area is 65 meters squared. Remember, folk, we've got to deal with meters squared because we're dealing with area. Got it? Next one. Our final one is finding the area of this triangle. Now, the formula for the area of a triangle, there she is there, is half times the base times the perpendicular height. So it's going to be half times 5 times the base. Now, do you remember, I've written it in there, but do you remember the original question didn't have the 12? How did we get that 12? We got that 12 by using Pythagoras' theorem. So, area is equal to a half times base times the perpendicular height. Okay, half, what's my base? 12 meters. What's my perpendicular height? Remember, here she is over there, 5 meters. Okay, so times 5 meters. Okay. Grade 11s. What's the difference between perpendicular height and a slant height? Okay. A perpendicular height means this. That if Ty, come back here. Got to
I saw
get
this
Ty to
happening.
work today. All right, Ty, I want you to stand like this, like you're thinking, but just like that. All right, so if I wanted to measure the height of the triangle, let's complete the triangle. Oh, you're a bit big there. Okay, so let's complete the triangle. So here's the side. Here's my 90 degree. Can you see it? There she is there. Here's my other side of the triangle. Now, the perpendicular height is the height where the base and one of the sides of the triangle meet at 90 degrees. Okay, so they're meeting at 90 degrees. We got that? What is a slant height? A slant height is any height from anywhere to the tip of the triangle. So it's not perpendicular, it's not 90 degrees. Check here, this is not 90 degrees. Can you see this angle here? It's not 90 degrees. Here is a 90 degree angle. Got that? I like you standing like it. I think we should just like both. Yeah. Here you go now. Right. Okay. So you've got to understand that. And sometimes in an examiner will try and trick you. And he will give you a different height. And so many people make the mistake and put the wrong height in. Okay. But you're not going to do that. Of course not, because you've learned something today. So let's take out our calculator and do this whole calculation. We're going to move it over there so we can see our figures. We've got a half. Now, guys, I can do this on a fraction button, or I could have actually just said 0.5. So a half times 12 multiplied then by 5 equals, and I get 30. So my answer now is 30 what? Meters squared. Okay. So let's fill that in here. So the area is 30 meters squared. Right. Let's see if the perimeter and the area are linked together. Right. For this exercise. Okay. Right. So who had our highest perimeter? Our highest perimeter was our rectangle. In second place was our circle with 31 meters. And in third place, our perimeter went to the triangle with 30 meters. Now we're looking at area. An area. Who gets our first place? This is interesting. Our first place now goes to the circle with an area of 78,5 meters squared. Okay. Who's in second place? In second place is the area of my rectangle. And in third place, way down here, is the area of my triangle. Now, folks, I want you to look at something here. Okay. In perimeter, it's like we've gone out and we bought some fencing. And with that fencing, we're trying to make the biggest possible area that we can make. Right? So, if I look at this perimeter here with 31 meters of fencing, I'm able to make 78,5 meters squared area. With 1 meter less of fencing, I drop from 78 to 30 meters. Look here. 31 meters to 30 meters, so it's 1 meter less fencing, but I jump from 78,5 meters squared to a mere 30 meters squared. With 33 meters of fencing, I'm making 65 meters squared of area. Have you ever driven along a road? Obviously, that's where one drives.
Yes.
But have you ever driven along and you've gone, let's say, from Durban to Joburg, or even from Durban to Cape Town, right? And you look out in the farming communities, and you suddenly see, every now and then, there is a water kind of irrigation system, okay? that kind of works from the middle and has got an arm that extends out and it goes around in a circle. Okay? In other words, instead of having a rectangular field, we've now got a circular field. And so we now plant our crops in a circle instead of a rectangle. And you look at this and you think, yes, like this farmer's doff, eh? Why is he doing that? Well, he's doing it for two reasons. Number one, it's a nice kind of irrigation system. But most importantly, he maximizes his area, okay, with the same amount of perimeter. Got that? Okay. I think it's far too early for a break, so I'm going to tell you a story. Right, so here's my story. I'm going to give you a rectangle. And here's my rectangle drawn. This is 1 meter. 1 meter, 2 meters, and we're going to make this 9 meters long and 9 meters long. Okay. So how much fencing do I have there? I got 20 meters worth of fencing, haven't I? Don't I? Of course I do. Let's have a look. 1 meter. 1 meter is 2 meters. 9 and 9 is 18. So I got 20 meters of fencing. So this is like a real life story. I'm just changing the numbers a little bit. So my wife loves animals, absolutely loves them. And she came home one day and said to me, you know what? We must make a chicken run. I want chickens, right? So off she went and she came back with 20 meters of wiring. And she said, I'm going to draw a plan and then you're going to go out there and you're going to make the chicken run for me. And that's what she did. So she drew this plan, 1 meter by 9 meters, okay? So the perimeter of fencing she's used is 20 meters. But there's a rule. And the rule is quite simple, that if you have a chicken, for every 1 meter squared, you're allowed 1 chicken. So we had to calculate the area, and that's what we did. We said, well, area is length times breadth. 9 times 1 is going to give me 9 meters squared. I have 9 meters squared, so I can have 9 chickens. So the chickens, we've got 9 of the little guys. And that kind of makes sense. And so she was very happy, drew her plan, and we went to bed that night. During the night, she wakes me up and says, hey, I've just been thinking, what happens if we do this? We now make 2 meters this side and 2 meters this side. Now remember, we've only got 20 meter fencing. Okay, we bought 1 roll, 20 meters. That's all we got. We had no money to buy any more fencing, and so 20 meters it was. So she says, all right, if we make 2 meters here and 2 meters there, how many meters are here and how many meters are here? Well, let's calculate it. We've got 20 meters. Minus 2 gives me 18. Minus 2 gives me 16. So I've got 16 meters to split each way. So I'm going to make this 8 meters, and I'm going to make this guy 8 meters. Ah, that's an interesting one. So now she says, right, do we still have 20 meters of fencing? And we do. 2 and 8 is 10, plus 2 is 12, plus 8 is 20. So our perimeter is still 20 meters. What is my area? Well, when we look at it, how do you calculate area? Area is length times breadth. So my length is 8 meters, my breadth is 2 meters. What's 8 times 2? 8 times 2 is 16. So my area is 16 meters squared. Now, how many area or how many square meters do I need for a chicken? For every 1 meter squared, I have 1 chicken. I've got 16 meters squared. How many chickens is that? It now means my wife can have 16 chickens. Now, I'm starting to panic here because my little house in the middle of Johannesburg is turning into a farm. And our neighbors are not going to be very happy with us. But you know what, guys? One major lesson you're going to learn in life, and I'm talking to the guys now. When you get married one day, you just keep your wife happy. That's the important thing, and that's the most important lesson to a successful marriage. And so my wife now says, cool, I'm going to have 16 chickens. And I'm thinking, oh my goodness, okay, fine. Good night, now go to bed. It's 2 o'clock in the morning. So she goes to bed. She wakes me up an hour later and says, I've been thinking. Now, guys, when your wife says, I've been thinking, that can only mean one thing. There's trouble, okay? So she says, what happens if I now make this side 4 meters and I make this side 4 meters? How much wiring am I now going to have left? Well, let's look at that, okay? So if I've got 4 and 4, I've used 8, I've got 12 meters left. Divided by 2 sides, I've now got 6 meters. And she says to me, now hold on, I want to know something here. Do I still have 20 meters of fencing? Yes, dear, you do. 4 plus 6 is 10, plus 4 is 14, plus 6 is 20. You got 20 meters. Can I get more chickens if I do it this way? Well, let's have a look. My perimeter is 20 meters. What's my area? My area is length times breadth. 6 times 4 is 24 meters squared. How many chickens does that mean? That now means 24 chickens. Now, folks, let's have a look at this. We're still using 20 meters of fencing, aren't we? Right? We haven't suddenly gone out and bought more fencing. But just the way we've designed our rectangle has given us more area. So when she designed it like this, I was kind of happy because we had 6 little chickens. So we used 20 meters of fencing, an area of 9 little chickens. Then at 2 o'clock in the morning when she woke up, our 9 chickens now evolved or developed or transformed into 16 chickens, because 8 times 2 is 16. Still 20 meters of fencing, but we've just put it in a different way. Finally then, we now look at this guy. 4 meters, 6 meters. Now 4 times 6, 24. Can you see what's happened? Same amount of fencing, but just by changing the shape, we're getting a different area. Okay. Here's the important thing. This is why when you are traveling along a road and you see a strip of land, very seldom do you see a thin strip of land with millies growing on. It's normally a huge rectangular, almost square. Square is actually the best shape because that gives you the maximum area. And that's why crops are grown in huge squarish type shapes instead of thin little rectangles, because your thin little rectangle gives you very little area to work with. But using the same perimeter, you're getting a greater area. Okay. That's exciting stuff. I find that just so intriguing, that with the same amount, and it costs you the same amount of money because you're buying the same number of poles, you're buying the same number of fencing, but you're able to maximize your area. We need a break after that.
Yes, we do. Need to make sure that the mindsetters now fence themselves in where they're sitting so they don't disappear. Anyway, moving along, moving right along, make sure you mindsetters get back and make sure you keep posting on the page. Thank you so much for those who are, but we'll see you after this break. And welcome back, mindsetters. Hope you had a nice little break there. You went to do whatever you had to do. You're now back, you're ready, and you're good to go. So now we actually got a message in via the Facebook page from Mark. So I think you've got the question, so you're good to go?
Right, folk. Absolutely. We got a question. Wasn't the question from Mark. It was a question from Belindy. Okay? And Belindy's asked this question, and I kind of enjoy this question. It's a lovely one. She said, so you've changed all these areas, just the dimensions, and got all different areas. What happens if you took 20 meters and made it into a circle? Would your wife be able to get more chickens? And that's a phenomenal question. So we're going to answer it. But it's quite a complicated little question, and I'll show you why. If you look here, you've got your perimeter, and hopefully Belindy, is watching and can understand this. But basically what we've actually got here is we've got a formula for our perimeter. There it is. Okay, and our formula for perimeter says perimeter is equal to, let's do this, perimeter is 2 times pi times r. We want to calculate the area, don't we? Now, in order to calculate the area, we know that area is pi times r squared. But we don't know what the radius of that circle is. All we know is the perimeter is going to be 20. So how do we now calculate the radius? So let's look at our perimeter formula. Our perimeter is 2 times pi times r. We know what the perimeter is. We know that the perimeter is 20 meters equals 2 times. What's my pi? It's 3,14 times my radius. So by doing our perimeter formula, knowing what our perimeter is, we can now calculate what the radius is going to be. When we know what the radius is, we can slap it into this formula, okay, our area formula, and then find out what the area of the circle is. Sure, that was a phenomenal question, Belindy, and we really appreciate it. So let's go for it. So 20 meters is equal to 2 times 3,14 times r. So let's calculate this part first. Out comes our calculator. Let's shift it to the side. We'll try and shift it to the side. So we've got 2 times 3.14, and we get an answer now of 6,28. So I've already got that 20 meters is equal to 6,28 times radius. And remember, I'm trying to calculate the radius by itself. Now, what's the sign between the 6,28 and the radius? The sign between those two is times. So when I get rid of that 6,28, what am I going to do with it? I'm going to divide. So let's do that. So we've got 20 meters divided by 6,28. Okay. Now, our calculator is going to do the work for us. And we say, right, 20 divided by 6.28. And our radius, is we're going to get a weird figure here, is 3,18. I'm just going to round it to 3,18. So my answer is, answer is going to be radius 3,18 meters. Sure. So we found out what the radius is. Now that we know what the radius is, we can now put it into our area formula and calculate the area. Here's the great question, folk. Is my wife going to get more chickens, or is she going to get less chickens in the garden by putting the fence in a circle? What do you think? Let's look. So pi is 3,14 times my radius, which is 3,18, squaring that, equals. Now, before we do that, let's have a look at our problem here. The biggest amount of chickens we've got is 24. Will we get more than 24 chickens? Our calculator is going to help us with that. So, here we go. We've got 3.14 multiplied by 3.18 squared equals, what's it going to be? There we go. 31,75. 31,75. Let's just get rid of that. Get rid of that. Let's try and get rid of that. We can't get rid of that, so I'm just going to talk now. So we got 31,75 chickens. Folk, what's the most amount of chickens we could get in a rectangle? The most amount of chickens we could have got in a rectangle was 24 of the little funny fluffy things. But now, by putting it in an area, or a circular area rather, we've now got a whopping 31,75 chickens. Now, folk, we can't have 0.75 of a chicken, It's not good to do that. You can't slot off the head and let this thing run around frantically like I think some of you guys used to do on the farm. I remember when I was a kid growing up, we saw people do. I would never do anything like that because I'm too good. But I saw people doing that. It was horrible. Cut off the head and the chicken. Oh, it's terrible. We're going to have the SPCA on us, so let's not even talk about that. So I can't have 0.75 of a chicken. But, so what am I going to do? Am I going to say I've got 30?
In the top corner there, just to help you out there, top corner, that X mark, just hit that one. We'll get rid of, that one.
Oh, cool. We're back on live. All right. So I can't have 0.75 of a chicken. So, folk, if I can't have 0.75 of a chicken, am I going to make it 31 chickens or 32 chickens? Now, if I were rounding up, I'd say 32 chickens. But guys, if I put in 32 chickens, I'm going to have the SPCA on me saying, hey, you don't have enough area for a full 32 chickens. So I've got to now round it down, and I'm going to round it down now to 31 chickens. So I think it's just been a remarkable question. I want to thank, what's her name, Belindy or something?
Yeah.
Okay. Thank her for that question, because I really think it's a phenomenal question. 20 meters of fencing, okay, and yet we initially started with 9 chickens. We've now got up to 31 chickens, and I really hope my wife's not watching this, because otherwise when I get home, that rectangular thing for 24 chickens is going to be ripped out the ground. She's going to have made a circle and said, that's it, get me more chickens. And on that note, I think we've got to sign off, because I've got to phone my wife and make sure she hasn't seen this program at all.
And she doesn't get any ideas.
Absolutely.
But on that note, if you're like Belindy and you had a question, make sure you keep talking to us on the page, post, and let us know. But this is where I now sign off and say thank you to you guys. And just want to say, keep on talking to each other. Use the page. It's for you guys. Tell a friend to tell a friend to tell another friend. But this is where I sign off and say thank you and see you next time.